So we are discussing about cables, right? Analysis of cables. Now for analyzing a cable structure, as you have understood very clearly that this kind of a cable structure will be subjected to a tensile force only, and who how the cable will be loaded? Cable will be generally loaded by some uniformly distributed load, okay, and the profile of the cable will be according to the distributed load which have been supported, just like in a simple supported beam. So in a simple supported beam, as the bending moment diagram of the simple supported beam supporting a UDL is basically looks like a parabola. The shape of the cable will be also like a parabola, because cable will not be able to take any kind of bending. It will be only resisting the load by means of taking tension in itself, okay. So basically this is, as we have previous class we have understood that this is the main cable. So the main cable will be under tension, and how this main cable will be loaded? This main cable will be basically loaded by the uniformly distributed load which is coming from this bridge deck and which is getting transmitted from this bridge deck to this closely spaced hangers. So when you place the hangers very closely, ideally the load from the bridge deck will be getting transmitted to the cable, and the load acting on the cable will be just like a uniformly distributed load. So that is what will happen in a main cable. Now this main cable will be passing over these supports. So these are basically the supporting towers, and on top of these supporting towers, here and here, as we have understood, there may be different kinds of supporting arrangement. The two types of supporting arrangements which is very commonly used, we have discussed in the previous class, that is, one is your pulley kind of supporting arrangement, and the other one is your saddles on the rollers. And you have observed that while the two different types of supporting arrangements, the load transfer mechanism to the piers as well as to the anchoring cables are little different. So basically, if you see, in case of a pulley, you have observed that in case of a pulley, the main cable and the anchor cable, whatever the tensile forces will be coming in the main cable, the anchor cable will be having the same amount of tensile force. But one point you should be very clear about in this point, that the inclination or the slope of this cable, that is the main cable at this support, that means if I draw a tangent over here, and if I take a horizontal line and I take a horizontal angle to that tangent, then the angle to that tangent of the main cable and the angle the backstay or the anchor cable is making with the horizontal, that means the angle making this cable, this backstay making with the horizontal, these two may not be equal, okay, or it may be equal. So whatever may be the case, you must remember that in case of a pulley, the main cable tension and the anchor cable tension will be equal, whereas in case of a saddle supported by this kind of rollers, you will be observing the horizontal component of the forces, that is this H2 and this H1 of these tensile forces in the main cable and in the anchor cable will be equal. So these points we have discussed in the previous class. Now based on these, we will be looking at a problem today. Let's see how to solve or how to analyze a cable problem. So let's see the problem. So you see what is being said in this problem. It's a simple problem. You see, a suspension cable 140 meter span of the cable and length of the cable are different, please understand this. Okay, span of the cable means support to support distance of the cable. Support to support distance is the span. Okay, and length of the cable means the curved length of the cable. So when you are talking about span of the cable, we are not talking about the length of the cable. Length of the cable is different. We'll take it up separately in the next class. Okay, so the suspension cable, when we will be analyzing, you see, we will be primarily requiring the support to support distance of the cable or the span of the cable. So a suspension cable 140 meter span and 14 meter central dip. So central dip you have understood, from the horizontal line at the bottom point of the cable, extreme bottom point of the cable, the depth is called dip. So that is your central dip, carries a load of 1 kilonewton per meter. So basically it is being said that whatever the load coming from the bridge deck that is being carried by the cable, it is basically UDL, uniformly distributed load, and the intensity of the uniformly distributed load is nothing but 1 kilonewton per meter. So calculate the maximum tension on the cable. So you will have to find out how much tension is getting generated in the cable. So see, that is the basic part of any cable analysis. See, in case of a cable, as I have said earlier also, and you must remember, there can be only one force, and that is only tension. There will not be any compression, there will not be any shear, there will not be any bending moment. Okay, so if you can calculate the maximum tension on the cable, that means you are analyzing the cable perfectly. So if you can find out how much is the maximum tension in the cable, from that you should be able to find out the area of cross section of the cable. Okay, now after that another question is asked, that find the horizontal and vertical forces in each pier under the following conditions. Pier means the support through which the cables are being supported. That means on the supporting towers, on top of the supporting towers, how much horizontal forces and how much vertical forces will be getting generated because of the load being carried by the cable. And the two conditions, for two conditions you will have to find out, and if you see these two conditions are nothing but the two support conditions as we have discussed. That is, the first one is if the cable passes over a frictionless rollers on top of the piers. So it's basically just a pulley. And second condition is if the cable is firmly clamped to saddles carried on frictionless rollers. So one is the saddle supported on roller, and another one is the pulley. Okay, so in both the cases, for both the cases you will have to find out how much will be the forces getting generated on the pier. Okay, now for these conditions, both these conditions, you are being said in this question that in each case the backstay is inclined at 30 degree with horizontal. Okay, so the backstay is inclined at 30 degree with horizontal. What does it mean? Backstay is inclined at 30 degree with horizontal means it is this one. So this is your backstay. Okay, so this is your main cable and this is your backstay. So the main cable inclination you will have to find out, and in the question it is being said the angle of inclination of the backstay. Now let us take step by step the problem. So what is said in the problem? 140 meter length of the 140 meter is the span of the cable. Okay, so cable structure. So to find out the maximum tension, so if you remember in the previous class we have discussed about it, that to find out the maximum tension T max, what you require? you need to find out what is your HA and what is your VA. That means what are the reactions at the support that you need to calculate, right? So if you can find out the reactions at the support, then you can easily calculate the value of HA, value of the tensile force in the cable. So if you see what are the values of HA and VA. So at the support, if you remember, at the support, if I go little top, then you see we have found out from the analysis that VA is nothing but your WL by 2, because on when the cable is supporting UDL, total load will be just getting transmitted to two supports, because there is no horizontal force as such, horizontal component is coming from that. So VA will be WL by 2, and if you see, if you observe, your HA will be equal to HB, and in such case, if you remember that taking moment about some point, we have found out HA in terms of this formula, that is HA equal to WL squared upon 8YC, where YC is nothing but the deep of the cable. You see, YC is nothing but the deep of the cable. So to find out the maximum tension in the cable, what you will have to do? You will have to first find out HA and you will have to first find out VA. So in the problem, if you observe, let me go to the problem again. So you see in the problem what you have done, you have just put the formula over here. So H is nothing but WL square by 8YC. Now what is W? W is the UDL which is being acted on the cable, and you see the UDL value is given as 1 kilonewton per meter. The span of the cable is 140 meter. So L is in this case is 140, and 14 meter is the central dip. That means 14 is your YC, value of YC. So you see, we will put the values over here. So W is 1, L squared 140 into 140, and then 8 multiplied by YC. YC is basically the deep of the cable, that is 14. So if you simplify it, if you solve it, then you are going to get the value of H. And what will be your V? V is nothing but your WL upon 2. So what is your 1? This is your 1, and length is 140 divided by 2. So if you divide it, so you are going to get 70 kilonewton. Now you see, once you get the value of H and V, what you can do? Once you get the value of H and V, you see the maximum tensile force, as you have seen, maximum tensile force is nothing but H squared plus V squared root over of that. Okay, so root over of H squared plus V squared is going to give you the maximum tensile force in the cable. So if you do that, you will get the value of something like this, and you will be getting the tensile force inside the cable. So the maximum tensile force inside the cable. Okay, now you see next question. So the first part of the problem is solved. So you see, it's very simple to solve. You will observe this: find the horizontal and vertical, calculate the maximum tension in the cable. So this part, you see, this calculate the maximum tension on the cable. This is very simple to solve. You see, if you remember two formula, or you can go from the very basic, that just calculate, just take the moment about some support and then calculate the V vertical force, and then for horizontal force you take moment about any point or moment about the central point of the cable, and then you know that in a cable, the every point, the summation of all the moments of all the forces taken about that point is equal to 0. So doing that, you can very easily get the value of the horizontal reaction component, and if you do square root of that, you are going to get the maximum tensile force in the cable. Now come to the next part of the problem, which is little bit, I will not say complex, but little bit conceptualized to understand, which already we have discussed in the theoretical part. You see, the next part is calculate the maximum tension on the cable. That is the first part. Then second part is find the horizontal and vertical forces in each pier under the following conditions. So you see what is being asked over here. You see for this case actually is being asked. You see this one. So you will have to find out when the main cable is having a tensile force T1, that means this is your T max or T you have found out. When the main cable is having a tensile force like that, and if there is a pulley like that, then how much force is coming over here on this pulley, how much horizontal force is coming and how much vertical force is coming, and that will be actually getting transmitted to this pier. And exactly the same way, if you are using a saddle support or a saddle on rollers, then how much will be the horizontal force and how much will be the vertical force on the pier. Okay, so that's what you'll have to find out. Okay, so now if you want to find it out, then what you'll have to do, you see, let us take case by case. So if I take the first case, in that first case you see, you know that T1 will be equal to T2 because it is a frictionless pulley. So if you go to the problem, you see in case of problem number, or in case of A, if you see this A, if the cable passes over a frictionless rollers on top of the piers. So if it is passing over frictionless rollers, then what will happen? This kind of condition will prevail. So what will happen? So this is a frictionless pulley. On one side there will be T1, on the other side it will be T2. Okay, so this T1 should be equal to T2 because it is a frictionless pulley. Okay, but you must remember that the angle which is the backstay or this anchor cable is making with horizontal is 30 degree. That is given in the problem. But you see the angle of this cable with the horizontal you will have to find out. So how do you find it out? So we have not discussed it in the previous class. Just let me go back little and show you how to find out that angle. You see, you have got the equation, of the cable something like that. So y is equal to 4yc by L squared multiplied by x into L minus x. That is the equation of the parabolic cable we have got, and basically that is the second order of parabola we have said, right? So if you want to find out how much is the angle that cable is making or tangent at any point is making with the horizontal, then what you have to do? You can do the dy dx of this, right? So to find out the slope of the cable at a particular point, what you can do? You can do first derivative, you can take first derivative of this. So y is equal to 4yc upon L squared into x into L minus x. This is the equation of the cable. So you do differentiation to take a first derivative. So what is happening? Dy upon dx, that is equal to, see, 4yc upon L squared. This is constant term because you see what is yc? Yc is the basically the deep of the cable. So deep of the cable is constant, length of the span is constant. So 4yc upon L squared, this term is basically a constant term, and then you see you have Lx minus x squared. So if you differentiate Lx, you are going to get L, and x squared will give you minus of twice x. So if you want to find out what will be the value of theta, exactly at this point, that means at the support, that means what is happening? From this point the cable is being started. So at x equal to 0, if you calculate this value of dy upon dx, you are going to get the value of tan theta 1. So tan theta 1, thus at x equal to 0, if you see, if you put x equal to 0 over here, then 2x will become equal to 0. So you see 4yc upon L squared multiplied by L, that is going to give you 4yc divided by L, because this L and one of this L will be getting cancelled out. So tan theta 1 at x equal to 0, that means the slope of the cable at just at the starting point of any pair will be given as 4yc upon L, and from that you can get theta 1 is equal to tan inverse of 4yc upon L, and this formula actually will be using while solving this problem, you see, because you need to know this value of theta 1. If you want to find out the horizontal component of force and vertical component of force because of this T1 and T2, in case of frictionless pulley, as you know that T1 is equal to T2, you know this angle theta 2 because you know what is the angle the backstay is making with the horizontal. However, you don't know what is the angle this cable is making with the horizontal. So you will have to find out the angle the cable is making with the horizontal. So how do you find out? You have understood now. So theta 1 is going to be equal to tan inverse of 4yc upon L, which is, if you put the values, so you know what is yc. Yc is equal to 14, that is the deep of the cable, and what is L? L is nothing but the length of the cable. So if you simplify it, if you solve it, you are going to get theta 1 value as 21 degree 48 minutes. Okay, so just simplification. Okay, I am not getting into the calculation today because I think the mood is not there to calculate. Okay, so let's just see the problem, the steps today. Okay, so if I now get the value, now see, now we have got the value of the main cable making with the horizontal, the angle the main cable is making with the horizontal. We know the anchor cable angle with the horizontal, and we know how much is the forces in the main cable and the anchor cable. So if we resolve those forces along the horizontal direction and along the vertical direction, that means if we resolve this force, this T1 and this T2, which are ideally equal, that is T1 is equal to T2 is equal to T in case of a frictionless pulley, then if we resolve this force along the horizontal direction, so if I resolve this force along T1, if it is resolved along horizontal direction, you are going to get T1 cos theta. So it is in the positive x direction, and this T2, if it is resolved in the x direction, it is T2 cos theta. So it is minus of T2 cos theta. It will act in the negative x direction. So your horizontal component of force which will be acting on the pier will be nothing but your T1 cos theta 1 minus T2 cos theta 2. Okay, so if you just put the values now, if you just put the values of your what is called theta 1 and theta 2 and T over here, so what is the value of T you have found out? Can anyone tell me what is the value of T you have found out? What is this T? Or what is this T1? What is this T2? Can anyone tell me? Hello?
T max.
Little bit louder. I cannot.
T max.
Okay, let me increase the volume. I cannot hear. Okay, T max, right. So this T, see, this T is nothing but T1 is equal to T2 is equal to T, which is nothing but this T max, because what is this T1? T1 is nothing but the tension in the main cable, right? So this T1, this T2 is nothing but equal to T, which is nothing but is your T max, and this is your 188.48. So you just put the value over here, 188.48, and cos theta 1. So theta 1 in this case is 21 degree 48 minute, and theta 2 is 30 degree. So you just put the values and you are going to get the horizontal component of force acting on the pier. Okay, and what will be the vertical component of forces? You see, the vertical component of forces in case of this, see, this T1 is acting in this direction, this T2 is acting in this direction. So if you resolve it in the downward vertical direction, so T1 sin theta 1 will come downward, as well as T2 sine theta 2 will come in the downward direction. So the vertical reaction force on the or vertical force on the support will be, or the PR will be equal to T1 sine theta 1 plus T2 sine theta 2, which is nothing but T sine theta 1 plus sine theta 2, and T is nothing but, again it is that 188.48, which we have found out earlier, which is basically the T max, that is the maximum tension in the cable. Please understand this concept, or this fundamental mathematical thing is valid in case it is a frictionless pulley, as well as it will be valid for a saddle support also. Only in case of saddle on a roller, you see this T1 may or may not be equal to T2. We will have to assume that T1 is not equal to T2. In case of a saddle on rollers, what will happen? You will have to, the equilibrium condition will be given as H1, that is the horizontal component of force in this direction, will be equal to horizontal component of force in this direction. That means the horizontal component of the tension coming in the main cable should be equal to the horizontal component of the tension, horizontal component of the tensile force coming in the anchored cable. That is the difference between the pulley and the saddle. Okay. Now, if you see, once you have found out H and V, after that you see, after that we will go to the next part of the problem, that is your this one, that if the cable is firmly clamped to saddles carried on frictionless rollers on top of the piers. Okay. So that means the next part of the problem, it is being said that instead of this roller, instead of this pulley, if the cable is being supported on a saddle on top of the roller. So if the cable is getting supported on top of the roller, saddle on top of the roller, you see what is the basic fundamental we have understood? We have understood that the horizontal component of the tensile force, see, please understand that being the support different, that is whether it is a pulley or whether it is a saddle on roller, the tensile force on the main cable does not change. You please understand this. There is nothing, that the tension in the cable, main cable, is not going to change. Okay. As well as you observe the angle the cable is making with the horizontal, that also is not going to change, because the profile of the cable will remain as parabolic, and the deep of the cable will be that YC only, that is the 14-meter deep only. It doesn't matter whether it is a pulley support or whether it is a saddle support. Only the mechanism of transfer to the support and to the anchor cable will change. Okay. So in the main cable there will not be any change in the value of the tensile forces. So the calculation of T max will be remaining exactly the same whether it is a pulley or whether it is a saddle on roller. Okay. Now you see the next point, if you observe that in case of a saddle, as we have said that H1 should be equal to H2. What is H1 and H2? See, H2 if I say, or you can say in this case here it is H1 and on this side H2, doesn't matter. Actually if you see, H1 is equal to H2 means the horizontal component of this force T1. What is this T1? This T1, you observe, this is nothing but the tension in the main cable. So you see this, the horizontal component of this will be T1 cos theta 1. And what is this theta 1? This theta 1 is the main cable making with the angle, the main cable making with the horizontal, which we have earlier find out in this, from this formula, that is theta 1 is equal to tan inverse 4 YC upon L. So using that formula, whatever value of theta 1 you have got, that is your cos, that is your theta 1, and in that you put that value, you are going to get cos theta 1. So T1 cos theta 1, that is the horizontal component of force or the tensile force in the main cable. And what will be the horizontal component of the force in the anchor cable? See, the horizontal component of force in the anchor cable will be equal to H2, that is T2 cos theta 2. And here is the thing you should understand, that you know the value of T1 but you don't know the value of T2, because in case of saddle support, this T1 and this T2 may be different, which is not the case in case of a pulley. In that case, you see you have got T1 is equal to T2. Okay, so T1 not equal to T2. So from this equation, from this horizontal equilibrium equation, you can easily find out the value of T2. So what will be your value of T2? T2 will be equal to T1 cos theta 1 divided by this cos theta 2. So that's why T2 is equal to this one, and you put the value of theta 1 and T1. What is the value of T1? T1 is nothing but your T max, which is the tension in the main cable, and we have calculated it earlier, that is T1 is equal to 188.48 kilonewton. So put the values and you are going to get the value of T2. Okay, so once you get the value of T2, then you see, then it's very simple. So once you get the value of T2, you can calculate the value of H1 and H2 very easily, right? Because in this case, you see, always your H1 is going to be equal to H2. So H1 is equal to H2 is equal to H, which will be nothing but T1 cos 21 degree 48 second. So, and your V is going to be equal to how much? T1 sine of 21.48 degree, sorry, T1 sine of 21.48 degree and T2 sine of this 30 degree. So if you calculate it, you are going to get the value of V. So you understand now what is the difference between a cable passing over a frictionless pulley and on saddle fixed to a fixed saddle on top of a roller. Is it clear? So see, the cable problems will be mostly looking like this. So you will have to find out the tension in the cable, you will have to find out the support reactions, that means on the pair how much is the horizontal force or how much is the vertical force, or you will have to find out how much is the tension in the anchor cable. This kind of problems you will have to solve in case of a cable. Is it clear to everyone? कोई आवाज ही नहीं देता है.
Yes, sir.
Yes, sir.
Okay, so if it is clear, then you see there is this type of cable, you see it's a very simple case. It's a very simple case where you see both the supports are at the same level, right? That means you see in this case, if I go over here, then you see just I go little up. See, if the two supports, see this cable is starting from this level and this cable is starting from this level. So that means this type of cable, if you observe, then you see the supports of this complete cable is at the same level. Okay, but there may be cases where the support of the cables may not be at the same level, and for that the analysis process will remain almost exactly same, but there will be little bit change in some equation. So I will not get into that details today. In the next class after Diwali we will be discussing this. So cable having supports at different levels. Sometimes in your in competitive exams as well as in your university exams, sometimes this type of cable profiles are given and you need to find out how much will be the tension in the cable. Okay, so don't worry about it. This is exactly the same process we will be following whatever we have understood for the cables which is supported at the same level. So when the cables will be supported at different level, then the formulation of finding out tension will be little bit different. Okay, so the conceptually it will remain same. Only the only the finding out of your horizontal component of force and vertical component of force will be changing little bit. That we will discuss afterwards. Okay, so I think up to this whatever we have discussed you have understood for the cable.
Yes, sir.
So only another one class I will take on this. Okay, after that we will be moving to indeterminate structural analysis. Okay, from the next another one class I will take on the cable after Diwali. Okay, then we will be moving to indeterminate structure analysis. That means the analysis of a propped cantilever, analysis of fixed beam, analysis of continuous beam using different methods. Okay, so we will be understanding the force method as well as we will be understanding three moment equation. Okay, so that is another one part of your structural analysis discussion. So up to this whatever we have discussed, that is analysis of arches, not arches, I should say analysis of three hinged arches, then cables, then portal frames. I hope you have understood it. Please go through the problems, please solve the problems, please do hands-on. Whatever problems I am sharing with you, please do hands-on, and if you have any doubt, please ask me in the next class. Okay, so I should stop here today. Let me take the attendance and then. So happy Diwali to all of you before I stop. Okay,
Thank you.
and also happy Chhath Puja to all of you. Enjoy your festive time. Okay, because I will not be having any class before Diwali. So happy Diwali all of you. Enjoy, but be cautious. Okay, don't enjoy too much. Okay, attendance is taken. Thank you.